In this question, it's asking us what mass of carbon dioxide is produced when 5.00 grams of calcium carbonate reacts with excess hydrochloric acid. Let's start off with the balanced equation then. CaCO3 reacting with HCl forms calcium chloride, CaCl2, and water, H2O, and carbon dioxide, CO2. That would need 2 moles of HCl for every 1 mole of calcium carbonate. You're quite likely to be given the balanced equation at GCSE for these sorts of calculations, so you should already be given that really in the question. Let's look at the mole ratio which this equation gives us. So this equation, if we read it in words, says that 1 mole of calcium carbonate reacts with 2 moles of hydrochloric acid to form 1 mole of calcium chloride and 1 mole of water and 1 mole of CO2, just like that. So it's a 1 to 2 to 1 to 1 to 1 mole ratio, just like so. We also know something about the mass. And the mass of calcium carbonate, 5.00 grams. We don't know the mass of HCl, but we know it's in excess, so that's irrelevant. We don't need that one. We're not asked about calcium chloride or indeed water, but we are asked about carbon dioxide, and we're indeed asked to calculate the mass of that, which I'm just going to call X for now. So to go from mass language to mole ratio language, we need the MR. So we're going to go calcium carbonate 100 for the MR, and none of these are relevant. 44 for carbon dioxide there. If you're not sure how to do those MRs, have a look back at the work that you did in the last couple of weeks and just make sure that you're happy where those numbers have come from. Convert those masses to moles then. Mass over MR gives us the moles. For this one then, 5.00 divided by 100 and 5 divided by 100, putting that into the calculator, is 0.0500 moles. Now, from the ratio, we can see that 1 mole of calcium carbonate produces the same number of moles of carbon dioxide, another 1. So if we've not got 1 mole, we've got 0.0500 moles. What we should actually produce is 0.0500 moles of the CO2. So the last step to this calculation is, well, how many grams is that? So answer to this one, then the mass of CO2 is equal to the moles, 0.0500, times by the MR, which is 44. And if you put that into your calculator, you should get a value of 2.20 grams. So notice the steps and stages in this calculation. Start with the balanced equation. Underneath that, the mole ratio. Underneath that, the mass that you know and the masses that you need to calculate. Underneath that, the MR. Work out the moles of the substance that you can work out at this stage. Convert by referring back to the ratios. Convert that number of moles to the moles of the unknown substance. Then work backwards. So moles times by MR gives you the mass. Let's do one more example. This time then, what mass of oxygen is needed to completely burn 2.30 grams of sodium? So again, start off with balanced equation. So we've got sodium and oxygen gas producing sodium oxide, which is Na2O. Let's balance this up then. 2 Na2Os being produced from 4 Nas and O2, like so. So this time the ratio is 4 to 1 to 2. That's the mole ratio, 4 to 1 to 2. The mass, we know that we've got 2.30 grams of sodium, and we're asked to calculate the mass of the oxygen gas. The MR then, well, for sodium it's just the same as the relative atomic mass, so that would be 23. And for oxygen, it's O2, so that will be 2 lots of 16, which is 32. Again, we're not really interested in the sodium oxide, we don't get any credit for that. Moles equals mass over MR. So for the sodium, 2.30 divided by 23 is 0.100 moles. Moles of oxygen, well, if we had 4 moles of sodium, we'd make 1 mole of oxygen. So to go from 4 to 1, we divide by 4. So to go from 0.100 to the moles of oxygen, divide that by 4, to get 0.0250 moles of oxygen gas. Final step then, the mass of O2 is the moles, 0.0250 times by the MR, 32. Let's work that into a calculator, and that gets 0.800 grams of oxygen. Now notice here, importantly, it's 4 moles of sodium in the equation, but the MR on this line here, the MR on this line is for 1 mole, and that's really important. So the MR is the mass in grams of 1 mole of that substance. As long as you remember that and follow this method, you can't go too far wrong. So have a go at some practice ones, please.